Newton's second law of motion can be translated into momentum form. So here and these are assumptions. For example, a body is moving with acceleration a, initial velocity v, I, b, f is equal to final velocity, and t is the time taken. So here we can define that acceleration is equal to change in velocity over time. That change in velocity is equal to v final minus v initial, and according to second law of motion, force on a body is equal to force is equal to mass into acceleration. Here we can define that acceleration is equal to force over mass. Here we compare these two equations. We find that f is equal to m, f over m is equal to v final minus v initial over time. So solving these equations, we find that force into time is equal to mv final minus mv initial. That mv is equal to momentum. So final momentum minus initial momentum means change in momentum is equal to f force into time, or we may say it force is equal to change in momentum over time, mean rate of change of momentum is equal to force. Here it is force rate of change of momentum, that is second law of motion. So a modified statement of second law of motion means time rate of change of momentum of body equals applied force. Here it is also to explain that in some time there is also change in mass of a moving body. For example, in a rocket, their burning fuel is exhausting through the exhaust pipe, so it is the mass of the body is changing with the time. So this equation can be applied to the rocket equation, where mass is also not constant, mass is changing, velocity is changing, so momentum is changing. That can be transformed in that form. So the second law of motion can be applied to rocket motion.